Welcome to the February 5th, 2018 Kubernetes SIG Apps. My name's Matt Farina, and so to get everybody going, I'll drop the agenda into chat here. I think that's the agenda document for our agenda and notes. The one thing that we have as an announcement is, again, I'll remind folks, we have the Helm Summit coming up. It's coming up in just a couple weeks, so if you want to go book your tickets, you can go there and get tickets, get hotel information, whatever. The last time I checked before the weekend, there were already over 100 people who'd signed up to attend, which is fantastic. And so that's the only announcement. Does anybody have any other announcements they wanted to share before we get started? Anything else? I'll take silence as no. All right, so the first thing we have up is a demo. Tom, are you on to share a demo?
I am. Can you hear me okay?
I sure can. The floor is yours.
Okay, great. So let me grab the screen share. Desktop screen. Cool. Can you see my screen?
I sure can.
Okay, great. So thanks everyone for coming. This talk is going to be pretty quick, so I'm going to jump right in. We think data operations like backup, protection, migration have traditionally been performed at the infrastructure level, for example, by taking individual volume level snapshots. This infrastructure level approach we think is wrong for stateful applications in the cloud native world. It doesn't allow developers to reason about application level semantics when performing data operations. Instead, we strongly believe that these operations should be performed at the application level, since it is simpler, more flexible, and most importantly, preserves application semantics. An application-first approach leverages battle-tested tools that understand and handle application-specific details. It also supports more complex distributed applications, as well as several other use cases. So, with that, today I'm presenting Canister, an open-source framework we've developed based on user feedback that allows developers and operators to codify application-level data operations and make those operations easy to perform. We hope that this will resonate with some of the other ongoing discussions of SIG Apps, and we look forward to interacting further around this. So, first a little bit about me and why I've been in the cloud native space for some time. My first job was at a startup called Imaginatics, where we worked on a cloud-based file system that was acquired by EMC. After the acquisition, I went to Dropbox, where I was on the core team for Database as a Service platform, doing metadata operations. This is one of the top 5 customers of MySQL. So, and then finally, a year ago, I joined Kasten with the goal of simplifying management of stateful applications in Kubernetes. So there are several applications that are only possible when working at the several use cases that are only possible when working at the application level. When you're infrastructure agnostic, you can easily move data between data centers or even between different cloud providers. If you want to move data from production for testing, at the application level, you're able to perform in-flight transformations of your data, such as masking a PII or downsampling to reduce your overall test set size. And finally, many complex applications require specific tools to perform data protection. So you can think of like big distributed applications. So you have point-in-time consistency. You need to have semantic understanding of the data. So Canister tries to address all of these use cases. We follow the operator pattern, which means there's a controller and CRDs, or custom resource definitions. So there are 2 types of CRDs in Canister. One is a blueprint, which encodes specific instructions for performing operations. The other is an action set. The action set collects all the inputs to an operation, and then once it's created, the controller will go and perform those operations. So here I'm going to kind of just walk through what that looks like. Let's say you have a Kubernetes cluster set up. We have a stateful application. We've deployed the Canister controller. We've already installed the blueprint. If I want to perform an operation, I can just use kubectl to create an action set. So because it's a CRD, it looks just like any other Kubernetes API object. The controller will see that we've created an action set. It will then take all the inputs and then look up in the blueprint to see how to perform the operation. In this case, we're going to run kubeexec, which is a Canister function similar to kubectl exec. This means that we can go run any operation inside containers that are currently running. Alternatively, Canister has a function called Kuby task, which will let us create a new pod that can then go perform operations like filtering or masking, that kind of thing. So finally, when this action is done, the Canister controller will go update the action set with the resulting artifacts and the status of the job. So that's kind of the top level diagram, but what I think is really interesting would be a real demo. So I'm going to switch over to this. This is pre-recorded, but these were live actions run. So let's get started. So let's see what's in our cluster. Right now we have the Canister controller running, and we have MongoDB installed. So to make this more interesting, let's input some data into the Mongo cluster. So in this case, we're going to add Roy's Restaurant, which is a Hawaiian diner. Okay, so that's installed. Now, one thing that Canister allows is configuration through config maps and secrets. So in this case, we're going to specify a config map that has the bucket where we want to push our data. So here, we're just going to push it to a bucket I pre-created called Canister Mongo, and we'll create that config map. Cool. Now I'm going to add some secrets, which I won't show here, but these give us access to that bucket. And finally, I'm going to create a blueprint, which will give us instructions how to perform these operations. Cool. Okay, so now I actually want to go and perform a backup operation. So I create my action set. Okay, my action set was created, but now we want to figure out what happened. So we can go look and introspect in the action set. In this case, I'm going to look at the actions here. So the long link there is where we actually push the data. This is an artifact. We also can see that there are several phases there was one phase that executed. In this case, we took a consistent backup, and that was completed. So in addition to storing the output inside the action set, we can also check the logs of the controller, which contain the full output from whatever operation we performed. So this is a lot here, but we can see in the middle that we've completed an upload, and we've pushed the tar of the backup to that backup. Cool. So of course, backups are only good if you can recover them. So first, let's destroy our data, simulating a crash. I'm going to drop everything from the database. Okay. And now I'm going to use a canister tool, which will allow me to chain action sets. So in this case, I'm going to chain off my previous backup action set, and I'm going to perform the action restore. What this does is creates a new action set with restore and passes all the output artifacts from the previous action set into this new restore action set. Cool. So now we can check the status on that, and we can see that the final phase is completed. Just to make sure I'm not lying, we can go and check to see what's inside of the database. So if we do find, we can see that we've successfully recovered our precious data about Roy's Diner. We know it's Hawaiian cuisine. So that's the demo. And now I just wanted to show a little more details on what a blueprint and an action set look like. So this is a blueprint. It looks just like a native Kubernetes API object because it's a CRD. A blueprint contains a list of actions and operations you can perform. In this case, we have one action called a backup. Any action can have one or more phases. In this case, we have one phase, which is just run through kubeexec. The first three parameters to kubeexec are where to run, so the namespace, pod, and container. And then the remaining parameters are the command we want to run. So in this case, we're using bash to invoke Mongo consistent backup. So the corresponding action set is also a CRD. So it just looks like, again, a native Kubernetes API object. In this case, you can specify sets of actions that will be performed in parallel. Here we're going to do backup. We're going to reference the blueprint we created before. And we're going to perform it on a stateful set. So the current options are stateful sets or deployments. We recognize that there's higher level groupings that the SIG is working on, specifically applications. And so we want to work with the community to figure out how to incorporate that into Canister. But for now, you can run on stateful sets and deployments. And then finally, you specify all the configuration you want. So you list all the config maps that you want to be made available inside the blueprint. So there are many reasons why you should use Canister, but I think we made a good case for running operations at the application level, which you can do through Canister. We're also working on a large library of blueprints, which we're trying to encode community operational knowledge into. In order to use these blueprints, it should be relatively easy. In the common case, you should be able to just modify configuration through config maps and secrets, but it's also very easy to tweak these blueprints for your own custom infrastructure. So with that, this is the end of the talk. We'd love to get your feedback on Canister. If you have feature requests or you want to contribute, these are all the links you need. So we have GitHub and Slack. Feel free to reach out to me personally. So there's my email, my LinkedIn. But with that, thank you. Any questions?
Is it fair to say then that the actual underlying infrastructure that is running some of these applications is not in the purview of Canister? So in your example, you had Mongo as something that you restored the actual application data from, but what about the Mongo cluster itself?
Yeah, it's a great question. I think one of the key points of running things at the application level means that you have to integrate closely with both the application and application-specific tools. So in the example I ran, we ran the backup directly in a sidecar of Mongo. The reason for that was because we actually wanted access directly to the Mongo volumes, and then we used Mongo-specific tools. In this case, it was Mongo Consistent Backup, which is a tool used by Percona, but it was developed specifically for MongoDB. So the point of Canister is to really run things, that are tightly coupled with your application. Does that answer your question?
It does, thanks. I was just trying to kind of compare and contrast this to HeptioArx's mission and kind of purview, and that does make sense. Thank you.
Yeah. Great question, thanks.
Does anybody else have any other questions?
I have one more if nobody else does. I'm just curious, similarly, is there the concept of a cron job type Canister deployment where this could be done, on a scheduled basis?
So that's not part of Canister itself, but you could imagine just using like the Kubernetes API to go and create these things. So if you have your own scheduling mechanism, like you could create a cron which would go in and run these action sets. But that is kind of outside the purview of Canister. But that is a good feature for sure. So.
Any other questions? Going once, going twice. Thanks. Thank you for the demo. This was good. This was neat. I'm going to dig a little bit more into it.
Yeah, please do. Thank you.
All right. Next up on the agenda, we have Vishnu. Are you on? This could be pretty short if he isn't here to bring this on.
I don't think Vishnu made it today, but I can speak in his place.
Okay. Then, Ken, the floor is yours to talk about machine learning.
Well, in brief, all we wanted to assess. Can you guys hear me?
Yeah.
Okay. In brief, all we wanted to assess was whether there was an interest from this SIG in machine learning workloads and potentially in participating in a working group to make sure that we're building the right primitives for Kubernetes to help run these workloads well. And there's a lot of other interest in other SIGs and other communities in ML, particularly SIG Big Data. There's a new community opening up called Kuby Flow, which is kind of a set of tools to help you build machine learning pipelines on top of Kubernetes. It includes things like Airflow, TensorFlow, Spark. There's an OpenShift working group that is focused on machine learning and OpenShift, and we're not really trying to focus on any of those things. We're trying to focus on making sure that we're building the right things inside of core and as extensions in order to support machine learning on KAS. So I just wanted to kind of open up the floor and see if any of you guys were interested in these type of workloads, if you're running them in production or if you're running them for experimentation, and if you would want to participate.
I would definitely participate. Our group is doing a lot of work with Kubeflow and the SIG big data out of OpenShift, and it's pretty much all we're doing is machine learning on top of Kubernetes and whatnot. So it's at least one vote of yes, I would help.
Awesome. Anybody else or? Okay, so I mean, really, that's all we wanted to discuss and just kind of see if there was an interest from this SIG. And it seems like there is at least one or two people. So we'll follow up and take an action item to, if we do a working group or however we decide to get together, because a lot of the concerns for machine learning are cross-cutting. They involve SIG node, they involve SIG network. However we organize, we just want to make sure that you guys are represented, we're represented in the working group. So I'll take action to follow up and make sure that whatever happens, we keep you guys abreast.
I do have a question though. How does this differ from the work that's going on with efforts like Spark on Kube and like we already mentioned the big data SIG? Like what machine learning is such an overloaded kind of term in some ways. Like what specifically, or if you have it, what kind of specific details would this new organization be really attempting to address?
So, well, okay. So for Spark in particular, Kubernetes came from a place where we started with serving workloads. We've made some headway into addressing stateful workloads. Data processing workloads, if you look at the core batch mechanisms like job, they're really not great for high performance data proc. Spark is kind of where we made an inroad there. Now you have ML Live for Spark, which is definitely something that would be of interest for like linear regression, for instance, or batch inference. But there's also other types of machine learning. TensorFlow, for instance, is generally deep neural nets, deep learning. And that has its own set of challenges. And with Spark, we were trying to address things like data locality, making sure that you can co-locate the Spark executors next to your nodes if you're running HDFS. But it's a different set of challenges because those workloads are still primarily IO bound. When you get into machine learning, particularly training, now you start having CPU intensive workloads, potentially memory intensive workloads as well. So the set of concerns might include things like cache interference, NUMA awareness, these type of challenges. And we're not trying to be opinionated. Like Kubeflow is somewhat more opinionated. It's here's a set of tools that we think are valuable and the community thinks are valuable that we're going to invest in to help you get started. They're not really saying this is the only way you should do it or being so opinionated to the point they're not listening to users' needs or having empathy. But there's a little bit more of opinionation. Like from the level of concern we're trying to address, if you want to use Caffe, we want that to work well for you. If you want to use PySpark, we want that to work well for you. If you want to use TensorFlow, we want that to work well for you. So trying to make sure we're building the right things and trying to make sure that we're addressing the concerns of our actual users.
Okay, so if I understand you right, then this is like pushing beyond kind of the initial thrust of Kubernetes, which is like running, like you kind of said, jobs or running workloads that are based around processes and whatnot that look more or less like standard OS type stuff. And you really want to address the specifics that are coming out of like analytics and machine learning workloads and try
Correct.
to make. Okay, cool.
But with ML, we're trying to really focus on ML and not so much data processing workloads. But data processing is generally, like for a typical ML practitioner, staging their data, sanitizing their data are all steps that they're going to have to execute a machine learning pipeline to do any type of training, let alone prediction. We think we have the right things for prediction serving, but really we've only tested it on TensorFlow at this point. There are some other people who are out there using other forms of prediction serving. But serving is still basically a stateless serving workload. So we think we handle that well. The training components, we would definitely want to have discussion in the community around. And we want it to be a discussion that's agnostic to whether you're running it on AWS or Google Cloud or OpenShift and agnostic to whether you're running TensorFlow or Caffe or Spark ML, or sorry, ML Lab.
Okay, so it sounds cool. I mean, it sounds like the data interaction stuff may be like a new kind of level too. Like you say, anyways, yeah, very interesting.
Yeah, I mean, there are definitely challenges with the data processing. Data gravity in specific is kind of one thing that's a large challenge in the space. And then hybrid deployments where you might have data that spans multiple regions, trying to schedule your workloads well there, or maybe even migrating data from one region to another, or migrating from an on-prem deployment to cloud. These are all challenges that are kind of in the data processing space, but are also a large challenge for machine learning practitioners.
So just for my notes, what you guys are calling this, like SIG machine learning or something, or what are you trying to name this, I guess?
We don't want to have a SIG because we don't think that, at least initially, we don't want to have a SIG unless it becomes something where people want to have a type of organization that lasts forever. We just want to bring people together for a temporary working group with the mandate of assessing the current suitability of Kubernetes to machine learning, finding where the friction points are, where the pain points are, where the limitations are, and at least coming up with a path forward to address them. But we look at it as a working group because working groups tend to have a temporary lifespan. They're not necessarily forever. And then they tend to bring in people from many SIGs, which is kind of what we're looking to do. For instance, we're here with SIG Apps because ultimately we think people who are designing tooling around Kubernetes and who are running applications on it are going to be the end users. SIG Node, we want to participate in because we're running potentially CPU bound workloads and ones that may benefit from isolation for memory. Knowing about kubelet and interacting with kubelet is important. Also, I think the accelerators, the hardware accelerator guys are in SIG Node for the most part. And then SIG Network, again, because storage bandwidth can be a huge limiter for distributed machine learning. So getting all of those people together in a working group to have a conversation is kind of the overarching goal.
Awesome. Yeah, thanks so much for going into detail about that. I appreciate it.
Yeah, it might just be worth noting that you're probably not going to see that many new SIGs come up. In fact, there's been talk about consolidating SIGs because there's just so many. There's maybe 30 of them now. And look at other sub-projects to existing SIGs. The way we have several sub-projects, many of the other SIGs don't, and there might be multiple SIGs with cross-cutting concerns, and looking at that kind of thing. And then working groups when you want SIGs to cross with each other. Just because, SIGs tend to be extremely long-running, like years and years and years, where a working group might come together to solve a problem, and then SIGs will end up owning the code at the end of that, and then the working group can dissolve because it's not needed anymore. It's kind of there to solve an issue that's there today, but maybe not there tomorrow.
Cool. Good reference point. Thank you.
And the other thing to note is that working groups, so a working group or a SIG, like SIG Big Data is a good example. SIG Big Data came around for a while. And then when there was no further work to do, it was kind of put on hiatus. And then last year, they brought it back for the Spark work. That does happen. Working groups usually, you can bring one back, but usually after it's complete, you have a fixed goal and a fixed outcome that the working group is desiring to achieve. And once it's achieved, you would just turn it down. But there's no reason to say you couldn't reopen the working group if the need should arise later down the line.
Sounds awesome. Definitely hit me up.
Will do. I'll make sure that as we're going to talk to SIG Big Data probably on Wednesday, and as we already have some interest from SIG Node, so as we kind of get more members together, well, I'll make sure to keep you guys abreast.
All right, thanks. Is there anybody else? Any last? If you do have interest in this, feel free to also reach out offline. Or if you know anybody who does, please reach out to them and let them know as we get into this, because the more input, the better something's made, the better it's tested, the better we're able to look into it. All right. At this point, we had open discussion, but there might be some other things. Does anybody have anything specific they want to talk about? If not, I have a couple other things we can jump ahead on that we haven't done yet. All right. So a couple of things that are coming up that maybe we could use some input on. One of them is it looks like SIGs are going to start getting charters together. We don't have definitive detail on what that's going to look like, but everything with SIGs has been pretty darn informal up to this point. And now they're looking to add a little bit formality to all of the processes, not so much to top-down institute what that will be, but to make sure it's documented and communicated and just clear for everybody. Like, how do SIG leads become SIG leads? What is the scope of a SIG, and how does, so one SIG scope compared to another SIG scope. And, I'm sure Ken, Adnan, and I are happy to go off and start doing some of this, but it shouldn't be done in a vacuum, right? Is there anybody here who's interested in helping us work on, and it'll probably be a couple weeks before we get started with the Helm Summit and some of the stuff coming up that we're busy with. Is there anybody who's interested in helping us put this stuff together and craft it, or having an opinion?
I would love to have an opinion, but unfortunately right now my schedule is really booked up with the Helm Dev Summit and everything else. But setting up that kind of stuff, I'd be completely interested in.
Okay. Since I wasn't even going to start on any of this until after the Dev Summit because, well, I got to come up with a presentation to talk about there along with a whole bunch of other stuff. And Adnan's busy with some face-to-face stuff. We're just kind of busy. So I was thinking that we'd probably start in early March after the Dev Summit. Would you be interested in helping then?
Yeah, early March would be great.
Okay. Is there anybody else interested? All right.
I guess I'm interested in what kind of level of commitment I guess are we looking for here? Like how much load do you expect coming out of this?
Probably not. We're just going to have to craft a document that says, here's some of the different processes we have, and here's some of the ones we think we have. And so we're looking for folks to help just craft those processes. Like, I'll be honest, most people probably don't know how SIG leads become SIG leads. And we should probably talk about that, maybe document it, and maybe change it. And I would really like input on how we should change that over time, because there's probably a lot better ways. Especially, the way it was started is just Michelle and I decided, hey, there's no place for this. Can we start something? And because we were interested in it, we became the SIG leads. Well, things have changed a lot in the last couple of years. And so we should look at how can we do better. And so I want input from folks. So we get input and we'll craft something up, and then we can bring it before everyone and probably debate it and discuss it, clean it up, and then probably just do a pull request to the community repo with what that is. And so I'm hoping it's just a few hours of everybody's time to just talk about what we think it should be, crafting some language. This isn't something crazy formal, and many of us are busy, so we don't want it to be, but just to make sure that the I's are dotted and T's are crossed.
Cool. I'm willing to lend a set of eyes and an extra read.
Fantastic. So for everybody here, can you go throw, if you're interested, throw your name onto the list that started in the notes of folks who are interested. And when we get going, we'll make sure to track everybody down and give you that option. So, and think about what you'd want if you're doing this in a SIG charter. Like, what are the things that you think should be in there? What have you learned? Matt Fisher, you're already the first line, but thank you for adding yourself to the notes. So just think about what you should have in there. And so even if you're not interested, if there's particular processes that you think should be covered by the charter, let us know and share. SIGs are not just a few people doing stuff. It's everybody who shows up and is involved. And so if you're here, you're involved. This is one of those things where it's like, hey, your 2 cents are important. So please speak up. It's your SIG.
I might have missed it. Was there a seed document for this already, or does that still need to be written?
No, it's being worked on. It'll initially come out of the steering committee probably, but as I understand it, their current go is they are more interested in wanting the stuff documented than telling everybody how to do it. So different SIGs will have different ways they do things, and they understand it. They're just asking for folks to get maybe a jump on it, and SIG architecture is going to do that, and Contribx is going to do that. And hopefully when we start in 2-3 weeks, we can grab some of their stuff as good starting points. This is getting a little bit of a jump on it, but they've kind of asked for some people to do that.
Yeah. All right, cool. Thank you.
Yeah. So there's that. Then the next thing that I'll throw onto this is they're also talking about coming up with a process for SIG related repos. Right now, you've got Kubernetes, and there's that organization, and the things under Kubernetes are like production grade, or grandfathered in, or big deal things. You got things like Minikube and Helm and Kubernetes, and some stuff that's been broken out of Kubernetes that's starting to go there. But it's things that are not experiments or toys, or where you try something new out. And so they're looking at some new processes to come in, and some documents have been floated around. I don't actually know where the link is, or I'd share it right now, or the current state of it, because it's been rewritten by the steering committee to look at, all right, there's these things that are part of Kubernetes. Then there are these maybe experiments and stuff that SIGs do. And they've talked about different SIGs having their own orgs. They've talked about having one org that all the SIGs repos go in, and automation to get stuff in there and manage it. A lot of it has to do with the manageability. Oh, by the way, whoever's doing the notes and cleaning things up, thank you. A lot of this is about the manageability of that stuff. And then they're looking at things that are maybe Kubernetes related. They're not owned by the Kubernetes organization or anything, but they're related. And I don't know exactly how they're going to get into the differences. If it's under the Kubernetes umbrella, it obviously has to have a CLA and a number of other things on it. But there is an opportunity for the SIG to say, hey, there are some projects we would like to do as a SIG that are related to Kubernetes experiments, whatnot, that we want to do, and what kinds of things would we possibly want to go in here. There's a big push to say most stuff should be done out in the ecosystem. Do it on your own. It doesn't need to be related to Kubernetes. And then if it's worthwhile and lots of people are using it, then maybe it's something that can be folded in if that makes sense. And so there's kind of this gray area of what makes sense to bring in that's an enabler to others, that's something related to Kubernetes but isn't really an ecosystem project. What would those look like, and what should we talk about bringing in and maybe doing in one of these repos? And I'm not suggesting anything at this point, and the process is definitely not outlined yet. I think SIG testing is testing a little bit of this as they iterate on it, but they're working on that. And so we should probably keep in our minds, what are the kinds of things we might want to bring in that make more sense to be brought in because they enable others. One of the things that I think Ken brought up to me last week is there is some stuff that they've been doing at Google. I think it's under the Google Cloud Platform org right now. That's about making it easier for people to write their own controllers. I don't know about you, but going in and writing a controller, that isn't necessarily an easy thing, right? Has anybody else here written their own controller? Who's not like on the controllers team or the no? And
So
there's some stuff, yeah.
Canister is itself a controller.
Yeah.
We actually looked at a bunch of different operator kits for this, which kind of helped get you started. The one we ended up using was from Rook. So Rook has this. I'll post the link in Slack, but it helps you get started with both the controller and the CRDs.
So one thing that's being worked on presently is called Kuby Builder. I mean, there are a couple of things in this space. Kuby comes out of SIG CLI. One of the leads of SIG CLI, Philip Whitrock, has been working on it. And it's a combination of a CRD generator and an aggregated API server generator. So to be more specific, you put your CRDs, again, I don't know how many people are familiar with working with Kubernetes in terms of adding core objects, but in Kubernetes core, you put your definitions in types.go, and then a series of code generators are run to do things like registers and shared informers. And ultimately, there's a repeated pattern that you use in order to set up a control loop the right way. What Kuby Builder does is just does all of it for you, because ultimately all of the controllers do pretty much the same thing. So with Kuby Builder, you put your types in and you run the code gen, and you basically just get, well, you run init first and it sets the project structure up. Then you put your types in, then you run the code gen, and all you have to do is fill in the reconciliation loop function, and all the other stuff is just done for you. So that's one. Another one that might be a fit, I think Anthony would be better to speak on it than me. Meta controller is being developed, which is kind of if you have a very simple controller that's just doing basic transformations, it's a way that you don't really have to do the code gen at all. It just pretty much handles it for you, and your entire controller is basically a webhook. So those were two of the kind of things that I was discussing that might be appropriate if there's interest in the SIG, because they're really made to lower the barrier to entry for tool developers and for people who want to generate their own controllers and build things that are going to be part of the Kubernetes ecosystem. I think one of my kind of personal experiences coming from a Mesos background is writing a Mesos framework could be on the order of 30 to 100,000 lines of code. And we don't want that to be the case for Kubernetes. If it requires that much code and most of it's generated, that's one thing. But we don't want people to have to continuously develop the same code again and again and again. There's a known best practice that we can auto-generate.
Yeah, that makes sense. And so we don't have a process for a repo yet, and so it's coming. And so we should probably, I just wanted to seed folks' minds to think about the difference between what's out in the ecosystem, if there's stuff we should have in here, maybe one or both of these or more things, what kinds of things, and how should we do that as a SIG? Just to kind of seed your thinking on it. So when that process does come out, probably in the next, hopefully a few weeks, but if I probably would have said the next few weeks, a few weeks ago, it's taking a little bit longer than I had anticipated. There might be a place to start talking about that and having those conversations. So just think about it. And with that, that's all I had on my mind. Did anybody have anything else they wanted to put into an open discussion or discuss? Going once, going twice, going 3 times. All right, thanks everyone for coming. As always, if you've got something throughout the week, come find us offline. We'll chit chat. Thanks everyone, and have a wonderful week.
Thank you.